They had categories that were somewhat similar to what was adopted by AASHTO, and hence the details that were in use at that time were somewhat different than what was adopted in 1974 when major changes were made. The design until 1995, which is only 15 years ago, was based on the HS-20 design truck for allowable stress design. It had 32 kip rear and drive axles and an 8 kip steering axle. And so this was the load condition that engineers use as they move this vehicle across the bridge with whatever method of analysis for the assumed structural situation that was used. The number of cycles at that time were selected from this type of table. They had main longitudinal load carrying. If you had a case 1, which was freeways, you had the average daily truck traffic of 2,500 or more, you fell into that category. You designed for truck loading, and truck loading meant the same loading that you used for strength, for capacity. So in other words, you might load, depending upon the number of lanes with more than one vehicle. There was a check that was introduced in 1971 and carried through into 1995 when the change was made, that if you use this load, you also needed to check what happened in the bridge for more than 2 million cycles, which I will deal with that separately as we get through this, for a single vehicle. And then there was lane loading that you had to deal with. So you had these load configurations that you needed to deal with. Now in the 1960s is when we started to actually carry out statistically controlled experiment design, where we were looking at all of these assumed variables that had some consequence on fatigue. Those would be the stress variables of maximum stress, minimum stress, stress ratio, or the stress range. Those were all looked at from a factorial experiment, including then detailed type, the influence of steel. Was in fact higher strength steel better than lower strength steel? So those are the many variables, and these were carried out on these types of specimens. And they've also revealed that inherent to the fatigue process of welded systems is defects, discontinuities. There is no welded structure that exists that has no defects. And in fact, I can recall back 30 years ago when General Electric thought they could build a wind turbine and have better fabrication of a welded steel blade for a very large wind turbine, and they found that it failed very quickly because the internal discontinuities and defects at the weld toe were no different from those that we have when we fabricate a bridge. So you do not change the discontinuity population. There is an inherent population of defects. We have internal flaws, such as you see here from porosity or slag that is trapped in the weldment. And as you can see from this cracked surface, there is a penny-shaped crack that evolves from that. And then once the crack penetrates all of the elements, it very rapidly turns into a multi-crack front, in which propagation is in all of those elements. If you go to a termination of a fillet weld, such as you have at attachments, then you find that the crack initiates from the weld toe at a micro discontinuity. So in one, you have internal discontinuities that you can see by your visual eye. In the other, you are dealing with micro discontinuities that you cannot see with your naked eye, and you cannot find with any known non-destructive tests. These discontinuities in the order of 1 to 20 mils. And I know of no one today anywhere in the world who can determine that such defects exist until after a test has been conducted. And if you look at this on a higher magnification, here we're looking at, as you can see from the scale, here's 100 micrometers. These are typically then at that scale level what these things would look like if you could find them. All right, so we have then inherent with the resistance of the process and an influence on its fatigue resistance, the fact that we have these type of discontinuities that are inherently going to be in your system.
We're having some technical difficulties, so could I interrupt you just for 1 minute? Beth is going to work on your computer.
No.
I'm
I'm
sorry.
terribly sorry. For some reason, we're not hearing you out there as well as we should.
Are you hearing me?
They're the ones who count, but
Say a few words, if you would. Oh, it's not coming through. Okay. Try this one more time. Check 1, 2, test, test. Okay, I see something there. Check 1, 2, test, test. Okay. Not hearing anything. Okay. Let me try something else and then we'll let you go.
Okay, please. Sorry.
Okay. You better close this down.
Totally forgot. You will want your slides, won't you? All right, so let's share our desktop.
Okay.
All right,
Okay. Thank you.
I'm sorry.
Sorry about that for those of you who could not hear.